Explanation of the electrical operation of an automotive air conditioning circuit. On the screen, we observe a diagram of the electrical circuit of an automotive air conditioning system. Below, we will explain step by step how it works. Step 1. At this moment, the air conditioning system is turned off. It is important to mention that this car shares the same fan for the condenser and the radiator, which is why, even though the climate control system is off, the fan is running, in this case at the first speed or low speed, to cool the engine radiator. Since the compressor is off under these conditions, the static pressure of the R134A refrigerant is approximately 90 pounds per square inch, which corresponds to a temperature close to 32 degrees centigrade or 89.6 degrees Fahrenheit at rest. Step 2. With the vehicle running, we proceed to activate the air conditioning using the corresponding switch on the control panel. Step 3. When turning on the system, the electrical current, in this case negative polarity or ground, must pass through the thermostat. The thermostat in this case allows the current to pass toward the compressor with the objective of subsequently turning it on so as to start the climate control system and reach the temperature desired by the passengers. Step 4. The current that goes through the thermostat before reaching the compressor arrives at the trinary valve. This valve acts as a pressure switch with two main functions: protect the compressor in case of low or high pressure, control the operating speed of the condenser fan. At this point, the current attempts to pass through the first protection switch of the trinary valve. Step 5. If the system pressure is between 30 pounds per square inch and 406 pounds per square inch, the trinary valve authorizes the current to pass to the compressor's electromagnetic clutch. Step 6. A current of approximately 3 to 4 amps enters the clutch's internal coil, generating a magnetic field. This field attracts the pulley and mechanically engages the compressor, starting its operation. Step 7. At this moment, the air conditioning system is already running. The fan continues to operate at its first speed, or normal speed, cooling the condenser and the combustion engine radiator, and the refrigerant now begins to circulate through the climate control circuit. Step 8. With the compressor running, the suction side pressure drops to approximately 36 pounds per square inch, which equals a refrigerant saturation temperature of 4.4 degrees centigrade or 40 degrees Fahrenheit. Simultaneously, the compressor discharge pressure reaches around 160 pounds per square inch, which corresponds to an approximate condensation temperature of 55 degrees centigrade or 131 degrees Fahrenheit. Step 9. If the external conditions are more demanding, for example, high ambient temperatures or more passengers in the vehicle, the thermal load on the system increases. As a consequence, the compressor discharge pressure begins to rise. Step 10. When the discharge pressure reaches approximately 254 pounds per square inch, the trinary valve activates its second internal switch, sending a control current to the relay that commands the second speed of the condenser fan. Step 11. The control current enters the relay through pin 86, energizing an internal coil that generates a magnetic field. This field attracts an internal switch inside the relay. Step 12. When this switch closes, the current coming from the battery flows from pin 30 to pin 87, reaching the electric fan. This fan now receives power that allows it to spin at a higher speed, which is essential to better dissipate heat from the condenser and reduce the compressor's discharge pressure. Step 13. When the thermostat detects that the set temperature inside the cabin has been reached, the mechanical thermostat opens its switch and stops the current from reaching the compressor, halting its operation. In this way, the system temporarily shuts off to prevent overcooling and maintain the temperature desired by the user.